Okay, your notes tonight are pages 131 and 132. Then you can jump to page 136, then page 139, and then page 141. We're kind of skipping around this area. You're going to be looking at ionic and covalent bonding. And so your reading goal is to describe how an atom becomes an ion, which you actually already know, it loses or gains an electron, and whether metals or nonmetals lose or gain electrons. You're going to compare and contrast ionic and covalent bonds and give examples of each. You'll describe the properties of an ionic bond versus a covalent bond. So in your notes, in your flip chart, you're going to describe how an ion forms and the charge, top of the first flap left side, so divide your flip chart in half. Explain if metals and nonmetals tend to lose or gain electrons, again on the top first flap left side. Define an ionic bond and give an example, top of first flap left side. Create a bubble map describing the properties of an ionic bond. You're going to do that at the top of the first flap right side. Then you're going to go down to the bottom, and on the left side define a covalent bond, define a molecule and give an example, and then create a bubble map describing the properties of a covalent bond. Then on the right side of the bottom, you'll create a double bubble map comparing and contrasting ionic and covalent bonds. So as we're going through this, I'll just talk about the notes briefly, and you should be taking your notes after you listen to this and you do your reading. Okay, just copying these isn't helpful, especially for the quiz. All right, so our first thing is defining an ion. And I think you guys should already know what an ion is from our last unit. An ion is a charged atom that either loses an electron or gains an electron. Remember, if it loses an electron, it's losing a negative charge. So then it becomes positive. It has more protons now. If it gains an electron, it becomes negatively charged. Okay, now metals, the left side of the table, okay, all the way up to the metalloids, are likely to lose electrons. And we talked about this during the periodic table unit. Group 1 tends to lose an electron. Group 2 tends to lose 2 electrons. Group 13 or 3A, the boron family, tends to lose 3 electrons, and so on. The nonmetals are likely to gain. So the halogens, which is group 17, they have 7 valence electrons. It's easier for them to gain an electron instead of losing 7. So the nonmetals tend to gain where the metals tend to lose. All right, so an ionic bond is the attraction between two oppositely charged ions to create a neutral compound. Okay, so you're going to have a negative and a positive that come together. So the example in the slide below is a really common one, sodium and chlorine, that we've talked about a lot. Sodium tends to lose an electron, so it becomes a positive 1. Chlorine tends to gain an electron, and it becomes a negative 1. And so they create NaCl. The positive 1 and the negative 1 cancel each other out, and you have a compound that is now neutral and stable and not reactive. Now, ionic bond properties for your bubble map. Ionic bonds tend to be hard, they tend to be brittle, there's crystals involved, there's some electrical conductivity, and they have really high melting points. And so that's what tends to happen when a negative and a positive bond together and form this ionic bond. Now, this isn't part of your notes, the writing formulas. However, we are going to be talking about this in class, so I'm just going to briefly discuss it now. You can write these notes on the back of your flip chart if you want to add them, but again, we're going to be doing this in class, so you don't necessarily need to do this. There is a term that you need to be familiar with called oxidation number, and this tells you if an atom loses or gains electrons. So the oxidation numbers must add up to 0 in a formula. So I was saying in the slide before that sodium has a positive 1, and a negative 1, and chlorine has a positive 1. So they tend to bond together. That tells me if they lose or gain electrons. So sodium has a positive 1, chlorine has a negative 1 because they're gaining an electron. So that's their oxidation number. So all the elements in group 1 have a positive 1 oxidation number. All the elements in group 2 have a positive 2. And then this helps you when we get to writing formulas. Okay, so the example is group 1 elements have an oxidation number of +1 because they lose an electron, or group 17 or group 7a, the halogens, have an oxidation number of -1 because they gain electrons. Now, these strategies for writing formulas, I'm not going to get into in this particular discussion, so this is something that we will do in class, but there's 3 ways that we're going to talk about writing formulas. Now, this oxidation number slide, I'm going to provide this table for you to glue into your flip chart. This just gives you the oxidation numbers of all the different families, even though this is something you could figure out on your own too. So let's move on to covalent bonds. And a covalent bond is a bond created by the sharing of electrons. So they're not becoming positive or negative. There's sharing going on with these types of bonds. They're usually formed when nonmetals bond together. Okay, it doesn't happen when a metal and a nonmetal bond. It happens when nonmetals bond together. Ionic bonds usually form between the metals and the nonmetals. So the attractions between the shared electrons and the protons in the nucleus of each atom hold the atoms together in the covalent bond. So water is a really good example of a covalent bond. And what happens during a covalent bond is they form molecules. And a molecule is a neutral group of atoms joined by a covalent bond. So when you hear the word molecule, that means it's a covalent bond. Okay, example is H2O. So oxygen has 6 valence electrons, hydrogen has 1. So for oxygen to get 8, it has to share 1 from hydrogen. And actually you have to have 2 hydrogen to fill it up. So that's why there's 2 hydrogen, H2, and then 1 oxygen. And again, we'll go into more detail on this in class, and we're going to talk about these little structures that are in this diagram called electron dot diagrams. They're really easy. Okay, and then we're going to talk about properties of covalent bonds, and this one's really easy. They have poor conductivity, and they have low melting and boiling points. So we're going to be doing a big lab called Let's Bounce, where you guys are going to be creating bouncy balls. And you have to determine whether an ionic bond or a covalent bond would make the best type of bouncy ball. And so that'll be the big lab that goes along with this. And we're also going to be writing some formulas, and you're going to be doing a chemical bond love letter to, which is really fun. So we'll do that in class. So this is it for the notes. And if it's not in the notes, you don't have to worry about it on the quiz. So you don't have to worry about writing formulas or oxidation numbers on the quiz.